Good morning everyone. Today, I'll be presenting on the hit or miss transform, a morphological operation used to detect specific shapes or patterns in binary images. It's particularly useful for identifying precise structures like T, L, or cross shapes, making it a powerful tool in image analysis and pattern recognition. Here's the agenda for today's presentation. First, we'll start with an introduction to understand what the hit or miss transform is. Next, we'll look at the mathematical concepts and basic erosion that form its foundation. Then, we'll go through the algorithm and implementation to see how it works in Python. Finally, we'll discuss the results, applications, and summary to review what we've learned and where this transform can be applied. The hit or miss transform is a morphological operation used in digital image processing to detect specific shapes or patterns in a binary image. It works by checking where a particular structure, called the foreground, and its surrounding background match exactly with a given pattern. In this method, we use two small matrices called structuring elements, one for the shape we want to find, B1, and another for the background, B2. By combining the results of erosion on both the image and its complement, the transform highlights the exact positions of the desired shape. The hit or miss transform is a method used in image processing to find a particular shape or pattern inside a binary image. Mathematically, it is written as a circled times B1, B2 equals a erosion B1 intersection erosion B2. Here, A is our input image and A is its complement. B1 is the structuring element that matches the object or shape we want to detect, and B2 represents the background around that shape. We first erode the image A with B1, and then erode the complement of A with B2. Finally, we take the intersection of both results. The common points show where the exact pattern exists in the image. Erosion is a basic operation used in image processing to make white objects in a binary image smaller. It works like this. We take a small shape called a structuring element, like a tiny pattern or filter, and slide it over the image. At each position, the center pixel will stay white, 1, only if the structuring element completely fits inside the white area of the image. If even one part of it falls on a black pixel, the center pixel becomes black, 0. So, erosion removes white pixels from the edges of shapes, making the object thinner or smaller. Now we will be learning the algorithm of the hit or miss transform. Step-by-step approach. Input binary image A. Define foreground SEB1 and background SEB2. Perform erosion of A with B1. Perform erosion of complement of A with B2. Compute intersection of the two erosion results to get final detection. This program shows how to use the hit or miss transform to find a particular shape, a T-shape, inside a binary image. We are using NumPy to create the image, OpenCV for the image operations, and Matplotlib to display the results. First, we create a 10 by 15 image filled with zeros. In this image, 0 means black and 1 means white. We draw a few small shapes, 2 T shapes, 1 L shape, and 1 plus shape, by setting some pixels to 1. This becomes our input image, where we want to find only the T shapes. Next, we define two structuring elements. They act like small templates. B1 is for the foreground, meaning the white T shape we want to detect. B2 is for the background, meaning the black area that should be around the T shape. Both of them are small matrices that help the program check where the shape fits. Then we find the complement of the image, called A. In this image, white becomes black and black becomes white. We do this because hit or miss looks at both the shape and its surrounding background at the same time. Before applying the operations, we convert all images to the 0 to 255 range, since OpenCV's erosion function works with those values. Then we perform two erosions. The first one, A circled minus B1, checks where the T shape matches in the main image. The second one, A circled minus B2, checks where the background matches in the complemented image. Erosion basically slides the structuring element over the image and finds where it fits perfectly. After both erosions, we take a bitwise and of the two results. This step shows only the positions where both the shape and background match exactly. That final image is called the hit or miss transform, and it highlights the detected T shapes. Finally, we use Matplotlib to show all the steps in a grid. The input image, the two structuring elements, the complement of the image, the two erosion results, and the final hit or miss transform. This makes it easy to understand how each step contributes to detecting the shape. Here you can see the complete output of the hit or miss transform. On the top left, we have the input binary image along with the structuring element B1, which represents the foreground pattern we want to detect. On the top right, we have structuring element B2, which represents the background pattern. Next to it is the complement of the original image, denoted as AC. This complement helps us verify the background match during the transform. In the second row, we see the two erosion results. The image labeled A eroded by B1 shows the locations where the foreground pattern perfectly fits into image A. The next image is AC eroded by B2, which highlights the locations where the background structuring element matches exactly in the complement image. Finally, on the right side, we have the hit or miss transform result, obtained by taking the intersection of the two erosion outputs. This final output marks the exact positions where both the foreground and background patterns match simultaneously. So the white pixel in the output indicates the successful detection of the target shape in the original image. The hit or miss transform has a variety of real-world applications, such as 1. Shape detection, identifying patterns like T, L, or plus in binary images. 2. Template matching, locating specific predefined shapes within an image. 3. Feature extraction, detecting junctions, corners, and endpoints in structures. 4. Industrial inspection, spotting defects or missing parts in manufactured products. 5. Medical imaging, recognizing particular cells or anatomical features in scans. These applications demonstrate its importance in automation and computer vision. To summarize, the hit or miss transform, HMT, is a powerful tool in morphological image processing used to detect specific patterns in binary images. It relies on two structuring elements, one for the foreground and one for the background. By combining erosion and intersection, it precisely locates shapes that match both structures simultaneously. Through our Python implementation, we saw how it accurately identifies shape locations, making it an essential technique in pattern recognition and image analysis. Thank you for watching my presentation. I hope this explanation of the hit or miss transform helped you understand how mathematical morphology can be used for shape detection and image analysis. Please feel free to share your questions or feedback. Thank you once again.